Okay, so I had to do a video about this now because I think I've just come up with another insight so far as it concerns space elevators, so far as it concerns the feasibility of this technology. What what the thinking about space elevators has been up until now, I think, is that we need to wait around for vastly stronger materials to be able to take the tension that will be on the cable from it, dangling in space, and yeah, we just need to wait around for things like carbon nanotubes and vastly stronger materials. However, what I've come up with is a design for a space elevator. It's a somewhat elaborate design at the moment, and this is kind of what I'm going to talk about in this video. Since it's got balloons, dirigibles, and rocket engines supporting all the stages up to about 150,000 feet or so. Beyond that, I was planning on using rings of rocket engines to get it to the Kármán line, and then beyond the Kármán line, once we're sort of in space proper, to then use solar arrays and ion thrusters to keep the tension off the cable, right? So what I was just thinking now, like, do we even need the turbofans and the rocket engines? Why not just have the ion thrusters in space, not pointing out, not yeah, like pointing out into space, but providing thrust back to the Earth, or keeping it nicely in balance there, and also relieving tension from the cable. Why can't we just do that? Why does the cable need to be pulled taut? Like, I was thinking of like gondolas, like you have at ski resorts, ski lifts, right? So yeah, like the cables on those aren't pulled taut. They're kind of slack a bit, aren't they? Why why do we need the jet engines? And also, like, the really troubling thing for me, like the really troubling bit for me, like, how much fuel are those rocket engines between the stratosphere and the Kármán line gonna burn? Because they'll need to be constantly pulsing, constantly just keeping the cable hovering, constantly correcting for the cable drifting around. I still probably think that you need rocket engines for the corrective stuff. Or I'd like to have them up there for that reason. If you see what I mean, it seems like it makes it more safe somehow in my mind. I'm really tired. Actually, I'm not tired. I feel like I'm in one of those like moods where, like, I should sleep. I'm trying to make myself sleep. I can't sleep. I think about this fucking shit. Not this shit, but this idea. Could it really be that simple? Could the answer be so easy and obvious, and no one's thought of it? No one's thought just to have a space station up there beyond the Kármán line, all supported by ion thrusters. But really, the function of the ion thrusters is just to relieve tension on the cable. And if it relieves tension on the cable, then we can use steel for it, can't we? That's steel cable, no need to wait for carbon nanotubes. Like space grade, like high, like very robust steel, sure, but nonetheless just steel. The physics of it doesn't upset my mind. Like, nothing strikes me as being glaringly wrong with that idea. But temperature on the steel, making more brittle, there's ways around that as well. Cold temperatures on the steel, making more brittle. Well, we can use other material, can't we? Like make it out of Kevlar. That sort of fiberglass enriched Kevlar composite. Something that nicely handles cryogenic temperatures and anyone out there like hazards. Am I correct to think that? Am I correct to think that we can have just a space station in orbit, ion thrusters on it, just counteracting that tension a bit, just keeping it a little bit slack? Then there's no need for these excessively high tensile strength materials like carbon nanotubes. And hence, like, really no need for dirigibles and jet engines. No need even for the rocket engines. So a cable going all up to space. Again, like for the corrective things, I want to keep the dirigibles and the jet engines and all that stuff. So yeah, like so it doesn't go like that, right? So it doesn't drift way out into the atmosphere and then snap. Which it it doesn't like go into a bow shape, right? It's probably I don't know what would happen exactly with them, but yeah, I am right to think that, aren't I? Yeah, I am. I think yes. Nothing glaringly wrong with the idea. Dirigibles, jet engines. The jet engines, because the dirigibles be providing lift, yeah, needn't be in use all that much, really. And yeah, the jet engines also, I was conceiving of it as though they need to be pointing upwards, actually, and firing this thing downwards to relieve tension again. But then I was thinking, like, probably up to 150,000 feet, I don't even think you need to relieve that much tension from the cable. I think that only really becomes a problem when you get out into space, don't you? Doesn't it? I really need someone to work with me on this. This has a lot of potential, this idea, I think. Well, no, I know it has potential because, well, it's based on a helium-assisted design for a space elevator that NASA was working on, though they didn't think to put turbofan jet engines on it. And in fact, I don't think I've come across an idea for a space elevator that incorporates any system of propulsion to relieve tension from the cable. There's a somewhat glaring problem with space elevators, but it's a problem that's very easily resolved. No, that's really the only insight I've had, I think. There's using some system of propulsion to relieve tension. And I've read, like, somewhere, I can't remember where, even with carbon nanotubes, it might not have enough tensile strength. Even if you have carbon nanotubes, you might also need engines on it. But I'm thinking, like, also about the environmentalist case, not burning too much fuel, not putting too much CO2 in the atmosphere. I don't think we might not even need any engines, except engines up at the carbon line, or ion thrusters up at the carbon line. Feedback much appreciated, thank you.